Welcome to another video from itech-blog. Today we will discuss how to install SQL Server on OpenShift. We will be using SQL Server 2019 and OpenShift 4.6. If you are not familiar with OpenShift, OpenShift is a hybrid cloud enterprise Kubernetes application platform. OpenShift uses Red Hat Enterprise Linux and Red Hat Enterprise Linux Core OS. OpenShift adds productivity and more security features that are important to large-scale companies. To manage OpenShift, we use OpenShift Console and OpenShift Client. Kubernetes dashboard, if you see, has limited functionalities. Whereas with OpenShift Console, we can do almost all administration tasks. If you're interested to learn more on OpenShift, I will be adding more videos in the near future. Let's go to the detailed course outline. We will see how to connect to OpenShift Console and OpenShift CLI. For installing SQL Server, we will start with allocating persistent volume storage, followed by creating a persistent volume claim. Then installing SQL Server using deployment. The deployed application will be exposed by a service. We will then verify SQL Server installation, connect to SQL Server, show the SQL Server processes running inside the pod. And also, we'll test pod failures and how OpenShift handles creating a new SQL pod in seconds in another node. Let's get started. I am now connected to OpenShift using OpenShift CLI and also using OpenShift Console. Let's create a new project called MSQL, and we have to perform all tasks inside this project or namespace. To create a project, click on Create Project and enter the name MSSQL. That's all. Now we have to click Create. The project MSQL is now created. In this project, we are going to install SQL Server. So let's start with creating PV and Pvcs. To deploy SQL Server, first thing we need to do is to set up storage. And we need persistent volume storage. What is persistent volume storage? Persistent volume meaning the volume will remain available even after the pod crashes. This way, when a new pod is recreated by OpenShift, the same storage will be available and used by this new pod. So let's create the persistent volume, PV, and then claim this volume using persistent volume claim, PVC. This PVC can then be called inside a SQL Server deployment. To create a PV and PVC, let's now connect to OpenShift Console and go to persistent volumes. Now we have to click Create Persistent Volume. You can see a default YAML file here. We have to now edit this YAML file, give our storage path information, also mentioning the capacity, access modes, and persistent volume reclaim policy. Here I'm going to select the capacity as 15 GB and the access mode as read-write many, and the persistent volume reclaim policy as recycle. Make sure we have to select the correct path and the server information and click Create. That's all. We have our persistent volume created. Now we have to go ahead and create a persistent volume claim for this PV. Now click on persistent volume claims and click on create persistent volume claim. Now here we have to select a name for the claim, which I put MySQL data, and access mode, which we have selected read write many. So let's do that. And the size of the PV we set was 15 gigs. So let's enter 15 GB and click create. And you can see here, it is now bound to the PV, meaning we can use this persistent volume claim in our SQL Server deployment YAML. Just to point out, I'm not going to go into details of the YAML files. It's out of topic for this course. I will try to cover important fields in SQL Server deployment YAML, and you can learn more on YAML from OpenShift.com or Kubernetes.io. We can proceed to install SQL using deployments. We can select deployments under workload in the console and then click create deployment. As you can see, it's giving us the option to enter or edit the deployment YAML. I have pre-created the YAMLs and is available in the server itself. So let's connect to the OpenShift server and do an ls. Note that we are also connected to OpenShift API using the OpenShift client. If you do not know how to install OpenShift client, you can refer to my website itech-blog.com. I have also mentioned the link in the description below. Let's open the deployment YAML and see what the content is. We have the API version, the kind is deployment, and the name of the deployment, and the number of replicas, meaning we will have only one prod created. Now another important thing is the host name. MySQL instance, that will be our SQL Server instance name. And we are downloading the latest version of SQL 2019 from Microsoft. We will be using 1433 port number, and we are going with developer edition. You can see here the password for the essay. The password for the essay here will be read from a secret document. Now what is this secret document? Secret document is another object in Kubernetes or OpenShift. We will have to create this object using a YAML file. And in that YAML file, we have to name it. Name the secret name as MySQL and provide key and the value for the key. Remember, the value for the key will be in encrypted form. It's base 64 encrypted. And below here is a path where SQL Server will have the data and log files installed, the volume mounts. And the last, which volume SQL Server will use. If you remember, we have created a PVC, a persistent volume claim, using the same name, MySQL-data. So let's go and create the deployment. There are two ways. One, we can copy all the content of this YAML file and paste it here inside the console. Or we can directly run from the OpenShift client. In this case, I'm going to run from the OpenShift client. OC create -f deployment.yaml. That's all. The deployment is created. Let's verify. There you go. You can see here it's not ready yet. Why is it so? That is because it could be because it is downloading the SQL Server software before it can install. Look here, it's container creating. So let's give it some time. Looks like the container is still not created. Now let's see why it is not created. We can check the logs. Because the container is not even created. So let's do describe pod. Okay, so the image was pulled successfully. However, it cannot create the container because the secret MSQL not found. We have not created the secret for the SA password. So let's verify the same error using console. Go to pods. You can see the same error. Click on the pod. Go to the logs. Or actually you can go to the events. There you go. Error, secret MSQL not found. The exact error we saw in OC client. So let's go and create the secret. I have the secret YAML here. Let's check what is inside that secret YAML. It's very simple YAML with the name MSQL and SA password. Remember, password, it's an encrypted password, base 64. So let's create the secret. Okay, the secret is now available. Container creating error. Let's wait for a few minutes. That's all. The pod is now running. So once we create the secret, the failed container started running. And let's go to the workloads in OpenShift console. You can see the pod is now running. And in the deployments, we have one of one pods running. So we have only one replica. Now that we have successfully deployed SQL Server, let's expose the deployment so that we can connect to SQL databases. We will use the pre-created services.yaml for this purpose. We can copy the contents of the service.yaml and paste into the console. Copy. Now go to console, under networking, services, create service. Control A, Control V. We can see here the port number is the port number of the SQL deployment, and the target port is also 1433. Click Create. The service is now created. Let's verify from the command line. Cool. We can see the services are now available in the MSQL project. Let's connect to the SQL Server instance and run few queries. In order to connect to SQL Server, as I do not have a public IP, I will be using port forwarding. So we have to open another terminal and run port forwarding from there. And we can go to the current terminal and connect to SQL Server. To do that, first, let me check the port name. So this is the port name for SQL Server deployment. Let's copy that and go to another terminal and run OC port forward pod / pod name, some random IP, and the target port, which is in our case 1433, and click enter. That's all, the port forwarding started. Now let's go to our terminal, and before connecting, let me check the password for SA. The password for SA, let me copy that. Now we are going to use MS SQL CLI to connect to SQL Server. If you do not know how to install MS SQL CLI on Linux, I have a link in the description. Please check. MS SQL CLI with an S, server name, which is our local host, password which we just copied. Okay, let me run the port forwarding one more time. There you go. We are connected to SQL Server. Let's verify. Okay, MS SQL instance is installed. We have a developer edition of SQL Server 2019 installed. That's all. Let's exit from the CLI. Let's now check how to read SQL error logs. There are multiple ways to do that. We can connect to SQL Server and do a xp_read error log, or we can read it directly from the pod. The log will be stored in where_opt MSQL folder. So let's connect to the pod. To connect to the pod, first we have to know the pod name. Let's copy the pod name. And let's do paste. There you go. We are now inside the pod. We can do ls. We can do ls. You can see here the data and log file locations. Let's read the SQL Server error log. There you go. We got the full error log. SQL Server is starting at normal priority, how much memory, buffer pool extension, etc., etc. Let's check the data location. You can see here the master, tempdb, all files are located here. We can also verify the SQL Server processes running. You can see there are two processes of SQL running inside the pod. Let's exit. Now let's do a pod failure test. I will kill the SQL Server process from within the pod, and let's see if the pod is automatically getting recreated. To do that, let me get the pod names first. I'm connecting to the pod. Alright, we're inside the SQL Server pod. Let's check the process. You can see the process 1 and 10 are used by SQL Server. Let's kill one of the processes. At the same time, in another terminal, let's check the status of the pods. It's still running. I'm going to kill session 10. There you go, it's terminated. You can see the status is now changed to completed. Still completed. Let's give a minute. There you go. You can see that now it changed to crash loop back off. There you go. It's back to running state. The pod is now back live and healthy. Thanks very much for watching this video. And if you like it, do subscribe to this YouTube channel. Also, do visit itech-blog.com for more tech articles.